Hello friends, you are highly welcome to this class, and today we'll be looking at this important topic, polynomial and their factorization. In particular, we'll be considering the remainder and the factor theorem. So I'm going to state the remainder theorem and the factor theorem and see some examples and how to apply them. So for the remainder theorem, we have that if a polynomial f of x is divided by x minus a, the remainder is what? F of a. That's what remainder theorem states. So you have a polynomial f of x, a function of x. Then you are dividing it by x minus a. A is any real number, which could be 2, 3, 4, 5. It can be any real number. So which is your a. So we are saying that the remainder after your division will be f of a. So you are going to change the sign. Remember here we have x minus a, but yeah, if you change this minus, if you change the sign here, it will be what? Plus. So you are going to have f of what? A instead of f of minus a. It means if you are dividing the polynomial by x plus a, assuming you are dividing the polynomial by x plus a, for instance, then it means that here will be what? F of minus what? A. Because we are going to change the sign here. Whatever sign you have here, you change it. So the theorem is saying that if you divide a polynomial by this quantity, the remainder will be f of the number here. And what you are going to substitute will be negative of here, negative of this number. We are having minus a here. If you do negative of minus a, you have positive a. But if you are dividing by x plus a, if you do negative of positive a, you are going to have negative a. So you are going to, the remainder will be f of minus a. That will be the remainder in that case. That was the remainder theorem is saying. But a situation whereby your f of a is 0. If the f of a is 0, then this quantity x minus a is a factor of that polynomial, which means that x minus a can divide that polynomial without a remainder. And this is what factor theorem says. So factor theorem says that if the remainder is 0, then the divisor is the factor of that polynomial. So if f of a is 0, then this divisor x minus a is a factor of the given polynomial f of x. And this is the factor theorem. So we are going to look at how to solve problems based on the factor theorem and the remainder theorem. So the example we have here, which is our first example, we are asked, they ask us for what value of m is this quantity x minus 2 a factor of the polynomial x raised to power 3 minus 3x squared plus mx plus 2m. So we are looking for what the value of m, so that x minus 2 will be a factor of this polynomial. So the first thing we are going to do is to use the factor theorem. By the factor theorem, we are going to have that f of a is equal to 0. So factor theorem is saying that f of a will be what? 0. So what is our a? Look at the divisor. What is dividing the polynomial is what? X minus 2. Just as we have here x minus a, right? I told you that this quantity here, you are going to change the sign. What we have here is minus 2. If you change the sign of minus 2, you are going to have what? Positive 2. Just in the theorem, we change the minus a to positive a. So we are going to change the sign of this quantity. So you are going to do, so our a in this case is what? Our a is equal to what? 2. You change the sign of this from minus to plus. So positive a. So our a is what? 2. So we are going to do f of 2. So this implies that f of 2 will be what? Implies f of 2 will be what? 0 by the factor theorem. But what is this 2 here? 2 is what? 2 is what? A particular point of what? X. So anywhere you see x here, you are going to substitute it for what? 2. So here I'm having x raised to power what? 3. So I want to evaluate this thing, f of 2. So in this place, I will replace x with what? 2. So I have 2 raised to power 3 minus, I have 3 multiplying x squared. And our x is what? 2 here. I'm substituting 2 for x. So I'm going to have 2, then squared. Then I have what? Plus m. M is multiplying x, and our x in the function is what? 2. So I have 2. Then I have what? Plus 2m. Plus 2m. This quantity I wrote down here is my f of 2. Then we are saying that it will be equal to what? 0. We are continuing solving this. So this implies 2 raised to power 3 is what? 2 times 2 times 2, which will give us 8. Then 2 raised to power 2 is 4. If you multiply it by negative 3, you are going to get what? Negative 12. Then m times 2 is what? 2m. Then I have 2m there, 2m. And we are saying that this will be equal to what? 0. So if you do 8 minus 12, you are going to get what? Negative 4. Because you are removing a bigger quantity from a smaller quantity. 12 is bigger than 8, and you are removing 12 from 8. So our answer is negative. Negative 4. And we are going to have what? 2m plus 2m will give us what? 4m. Then we have equal to 0. So we are going to get our m. So we leave this, our letter m this side, and move number minus 4 to the other side, to the right. So in this place we have 4m. So we are going to move minus 4 to the right, change to plus 4. So I have 4. So what is the coefficient of m? Which is this number here, 4. So we divide both sides by 4. So divide both sides by 4. What I have here is 4m. I will do it over 4. So 4m over 4. Then I have equal to, what I have at the right is 4. I will write it and do it over 4. So I have divided both sides by what? 4. Then if 4 divide 4, I have 1, multiply m, I have m here. Then I have equal to here. Then 4 divide 4 is what? 1. So clearly our m is equal to 1. So it is when m is 1 that this quantity x minus 2 will be a factor of this polynomial. Which means that if m is 1, then x minus 2 will divide this polynomial without a remainder. So that's all about it. We are going to move in. We are going to look at more of this kind of example in our upcoming class. See you then. Bye.